Hello. It's just me this week, your host, talking about all the latest security issues, security bugs, security. I am also not dog sitting. My dog is here with me, my puppy. I don't think I've put him on the air yet. This is Obi for Obi-Wan. Say hello to the internet, buddy. He is awake. He was napping. So he may be making a mess of the room, which is also why you don't see a lot of the plushies and stuffed animals around, because they're everywhere. So he's going to be hanging out with me while we talk about the latest Docker issues. BuildKit, Runc, Docker, Podman, Containerd, Kubernetes. It affects everything. but it's not that big a deal, I think. It's not that big a deal if you were already properly controlling what you build and what you run on your servers. So we're going to talk about that. If anyone has any immediate questions, of course, we're going to go through a lot of stuff. I'm going to try to keep it short, but the end of this is open-ended. Like we could dive into mitigation techniques. We could test some things. I've got a bunch of servers set up if we want to try things. And I'm going to constantly be looking backwards to make sure my dog isn't eating the electrical wires. Okay? So welcome, everyone. We got all the regulars in town. Martin's here. Shrikanath, sorry if I mispronounced that. Ivan Shurazan, Shuttershawn, sorry if I mispronounced that. We got Adam, we've got, let's see, Ansa Q's here. 12-month membership, nice. I appreciate that. And you too can be a member, and then you can be on our Discord server, which everyone gets for free, but you get exclusive monthly memberships if you're in the High Fivers Club. You can read all about that if you just click on the join button. You don't actually join when you click the join button. You can get the options of what you want. And if you just want to buy me a coffee to thank me for this weekly live show that we've been doing now for like almost 5 years, you can do that. All right. So I'm assuming, hi Dax, Tony, what's up? James is here. John is back. What's up, John Kennedy? Results here from the Discord server. MW. Andrew Zizahari. Zazahari. Not sure how to pronounce that. All right, so Snyk. I'm wearing their shirt today. They didn't pay me to do that. I'm just going to wear it because they found a bug, which is good. That means somebody's working hard. And they found a list of vulnerabilities that affect Docker products. But they affect way more than Docker products. There is no tool on the internet that I know of anyone actually using that doesn't use Runc. And we're going to talk about what Runc is, how it's affected. But Runc is what actually is running your containers underneath Docker, underneath Podman, underneath Containerd, Kubernetes, Cryo, all of it. Runc is there, and it is the thing, it is the tiny binary that executes the thing in your container. And we can actually look at that through a process tree, and we can see that. And Runc has a high vulnerability. It is not remotely exploitable, but let's back up a minute and just talk about, before we get into the details of what each exploit is, the core premises that are broken by these vulnerabilities. And it's a set of them, and they do various things. They're all semi-related in the fact that this is a file system breakout of your container file system. And there's two assumptions that we really have in container land. One is that when I have all these notes, by the way. I've got digital notes, I've got paper notes, I've got pages and pages of notes that I've been taking for the last couple of days to kind of frame this conversation. But, Nitish is saying it's using crun. So we're going to talk about crun because I see crun, but everywhere I can see it, Red Hat, all their documentation talks about that it's Runc by default. So I was curious if anybody did that. The number of people using Podman on RHEL 9 is probably pretty low. So we're really talking probably, I'm just going to guess, less than 1% of the people, of the servers, of the machines that are running containers today in the world are probably running Red Hat 9 Podman. So virtually everyone is going to have to deal with this. And the nice thing is the patch is already out. You just update Runc. In some cases, you're going to need to update BuildKit. If you're someone who's just running Docker, Docker Swarm, Docker Engine, Compose, whatever, Docker Desktop, you just update whatever the thing is. If it's apt in Ubuntu, if it's Docker Desktop, just update your Docker Desktop to the point release, and you're fine. This cannot be exploited remotely by a remote hacker unless you already were exposing Docker or the Kubernetes API in an inappropriate way. The only way that you can really take advantage of this as an attacker is to get someone to build your Docker file that has a particular thing in it that shouldn't be, or run your container image that you have augmented, all right, to take advantage of this exploit. So it has to happen during either build time or runtime, but it can't just happen willy-nilly. It has to actually happen when things start, and it has to have a specifically crafted Docker file or Docker image that's going to take advantage of this breakout. So if you're running your own trusted software, if you're controlling the images that you put into production, if you are watching all changes in images, even the from images, which hopefully you're using trusted from images, either you're controlling them in your infrastructure or you're using something like the Docker official images. If you're in that world, then there's really no risk to you here, even on existing systems that haven't been patched, because as long as you're running your trusted code and you're monitoring for changes, the little lines that will show up, and we're going to talk about some tools to help you detect it, to help you watch for it. We're actually going to talk about some ways you can maybe block it. It's a little iffy there, but there's some things there, and a lot of people have been speculating and trying different ways. So we can, again, this could be a multi-hour stream. So the core premise of this whole thing is, let's just bring up some stuff. And I wrote down some specific notes. The facts of the case. The facts of the case are 6 vulnerabilities found across Docker Engine, BuildKit, and Runc by Snyk Security Research. That's actually, we're going to bring up their podcast and play a minute. But Rory McNamara was the researcher that figured it out. Good job, Roy. And he was on their security podcast, so we're going to listen to a little bit of that in a minute, just a couple minutes of it, where he explains a little bit of file descriptors and how that works in Linux. For those of us that are maybe not hardcore sysadmins, understanding file system layer activities in Linux. So these vulnerabilities, sorry, I have a cough drop in my mouth. These vulnerabilities are, they spread across high and medium. The core premise here is it gives something in a container during build time or runtime access to the host file system, likely as root. Because in most cases, I find that people are running their container runtimes as root, not necessarily in the container. That's totally different. But when you're running Docker Engine by default, if you're running Kubernetes, in most cases, most distributions by default, there will be admin access by the container runtime. Runc, containerd, Docker Engine. A lot of these things can be run rootless, which would help but not prevent the spread of this, vulnerability. Because if you break out of a container, you're breaking out into the host file system as the user that's running the runtime, not the user in the container, but the runtime on the host that executed your container to begin with. And so typically, in most cases, unless you're in a very secure, customly designed environment, or possibly in certain cloud environments that are running containers and they are designing it with something like Firecracker or Kata containers, which we're going to get into all that. But if you're doing that, by default, you're running as root. So if you break out, then you're going to be on the host file system as root. That's bad. If you were running rootless containers, you can still break out in this scenario. I haven't actually tested that yet, but you can break out, but you're now only going to be available to, you're going to only be able to access and control files that are of that user. Now, there's something that I've been a big fan of for years called user namespaces, which is similar to rootless mode. It's a little bit different. It allows you to have a little bit more capability. One of the big reasons a lot of people don't run in rootless is that networking is a challenge, and other things that you want to do inside of a container might not be allowed because your host runtime is rootless. And so in particular, things like overlaid networks just won't work, or exposing ports on the host network may not work. It just kind of depends. And there's lots of caveats. There's workarounds. There's configuration if you're in Rootless. If you're someone who's gone down the Rootless path, you know the struggle. And I find that honestly, in most environments, the people that try to go rootless can only do it for so much. Like there's only so much of their infrastructure that can go rootless, and maybe they use their most hardened and locked down applications in there, or maybe they're multi-tenant, which is a place where you definitely want as much security like Rootless. Another thing too is that as far as I know, AppLocker, SE Linux, and well, maybe not SE Linux, but AppArmor and SecComp don't help here. My understanding, according to the research from Roy, that you can't really identify the mounts and whether they're done by Docker. And so there's no real way to block easily there that he was aware of. So a lot of the security features that you might do as something is running in a container aren't going to help you here because of the nature of this breakout. All right. So unauthorized access to the host file system based on the permissions of the runtime that ran your container. You can basically, a lot of these vulnerabilities, if you're looking at this, they will talk about the build cache. That's why BuildKit's in here a lot. And the build cache is whenever you're building an image, it caches each layer while it's building it, and then it'll also store those after the fact in case you want to rebuild, and it will look for layers that are already cached and not rebuild them. But because during the build process, we're also using Runc to do things, and we're also talking to the file system from inside the container, this breakout is still possible there, and then allows someone to corrupt the build cache a little bit. And the details of each one is a little bit nuanced. You'll notice in the lead one, we're actually talking about the workdir. That's the big one that we're going to dive into, is the workdir command in a Docker file specifically is the way to take advantage of that. So as you get down to the BuildKit stuff, it's really about corrupting your build cache. So the thing here is that these other ones, if you maybe run, how would this be taken advantage of? I was asking myself that last night, and the way that would be really taken advantage of is something that's coming in the industry. It's going to be more popular as a style of attack. I actually just found some news very recently, actually from ChainGuard, pointing out, so I can find the news. But there was some news. I got a lot of links. Yeah, I'm not seeing it here. I'll find it later. But there was some news recently about attacks on CI platforms. And specifically, if you're someone that's using something like GitHub Actions, and you're using GitHub Action custom runners that you're running in your own environment, if you're doing that on open source, there are risks and inherent risks to that, because someone, if they give you a PR, and this all depends on how, in this particular case of GitHub, how you set up GitHub, but if you do it by default, this actually doesn't happen. You just have to kind of accidentally or intentionally turn this thing on. But you can actually run PRs from public pull requests that other people give you, and your CI might auto-test that or auto-run on that. And GitHub, to their credit, really gives you a lot of warnings about making sure that you don't do this, because that means that your CI would then run any arbitrary code. So in my scenario of, well, this is at risk for people with open source, that they have potential for untrusted PRs running on private CI runners, if you choose to do that, I don't really look at that as a likely, because one, you have to ignore all the warnings. And two, you have to be running private CI runners on open source projects that you allow untrusted people to create PRs on. So there's a lot there that you have to be willing to do. And then you have to have vulnerable runners, which means you're not updating your runners. If you use public runners, they're updated. They go through regular update cycles. Docker even talks here about their own CI runners that in their new Docker cloud builds that they use will automatically be upgraded. So I don't really look at the build system as a big risk, because someone still has to affect your supply chain. Someone still has to get in your supply chain, meaning how you get your Docker files, how you get your Docker images, and they have to change that in order to take advantage of this. So if they're already able to compromise your supply chain, then you already had a lot of problems to begin with, and this is actually just probably small potatoes at this point. But the one that everyone's talking about is the top one, is the CVE-2024-21626. And this is the one that affects Runc. And what is Runc? So let's pull up some stuff. I'm going to actually answer some questions real quick, but we're going to dive into some more facts and scenarios. All right, this is a good question. How do we remediate Runc vulnerability if we have Docker and Podman running multiple containers on thousands of hosts in an automated way? How is it done in production? Well, if you are running thousands of hosts, then you already, like a human didn't create thousands of hosts, right? And a human didn't manually, when I mean they didn't manually create each one. You probably had Terraform or CDK or something that was creating that infrastructure. And you already would have a way, usually, you would already have a way of replacing and updating that infrastructure today. I mean, this isn't the first time that those systems had to have updates. Docker Desktop, they wouldn't have Docker Desktop. They'd have Docker Engine, or they'd have Containerd, and all of those come with Runc. So if you're using Kubernetes today, that's a distribution. Almost certainly you're using a distribution. Most of you are probably not running vanilla upstream generic. Regardless of that, if you're on a vendor solution, then you go to the vendor, and they're going to probably have an update to the whole thing that will include Runc's update. If you are running your own vanilla, what we call that vanilla upstream, using kubeadmin or some open source tool to install the native bits from upstream, then you're going to have to update Runc manually, and you should have had already a mechanism to do that. So you're just going to roll through updating the existing Runc, restarting the servers one at a time or a group at a time. Infrastructure people that build out thousands of servers have ways to patch the thousands of servers, and this is just a standard patch. So I don't see any barrier to teams upgrading to the latest Runc. Now, this bug was introduced somewhere in 1.0 of Runc, I think. So it's been around a long time. Two things I want to point out from Snyk is, one, there has been no word yet of a publicly exploited system. And when they went and looked at Docker Hub at a bunch of common images, they found no evidence of any images with this in it. So we're talking about a theoretical outbreak of some sort of bad thing. Again, the supply chain of any of these things would have to be broken in order to inject this code. The reason that this is so important, because you might say, well, if I've already got secure lockdown Docker Hub and Docker files and everything's private and I control every change, then you're fine. Doesn't mean you can carry on blindly, but it does mean that your risk is really, really low. Someone would first have to break your supply chain of those Docker files, of your source code where the Docker file is, in order to do this, or to possibly change one of your from images to their image, which might have the exploit. So again, that's going to be unlikely if you're tracking all changes and controlling all versions of images that are in your production. What I normally see in larger enterprises, when they have thousands of servers, they're going to have their own registries, and their registries are going to have their golden images, or essentially the approved images that are allowed in production never come directly from Docker Hub or any other public registry. They're only coming from tested, scanned, and copied images that they manually approve via some process, a PR process, and some repo that will automatically move over images when necessary, and then only has the approved images and the approved versions that the DevSecOps team or whoever is approving, right? So when I see large organizations, that's how they do it. So there's no way that even if someone was to somehow break the supply chain of a Docker Hub image, it's unlikely that it's going to affect those images because they're using their own copies that are scanned, approved. There's a lot of rigor to making sure that these new base images don't get updated in a sneaky way. All right. Let's see if there's any questions. Oh yeah. So how do we remediate? Update. I mean, that's a standard. I know it's a kind of a lame answer, but there is no universal works in every scenario kind of way to block this at the Runc level. There are tools to identify it, but they don't block. There are tools that we can talk about and possibly in Kubernetes land that could possibly block, like Kyverno. But I've already seen people sort of figuring out ways to get around simple little file path checks where maybe the file path is symlinked, maybe the file path in this exploit that tries to break out of the container, maybe the text that might be searched in a simple search query, that text might be encapsulated or encoded so that it fails in simple regexes. So there are, I think, a lot of ways around this very sort of benign accessing a directory that will then inevitably cause a container breakout. There's so many ways. It seems like that there's not a tool that you can simply just shim in at runtime, not affect anything currently running to somehow prevent any new container from mounting the file descriptors. So at least that's my research. So the true and fixed, the mitigation there is to just upgrade Runc. And as far as I know, one of the challenges is going to be is if you're not on the latest Runc versions, they're compatible in Symver's way because they try to follow strict Symver. So all the distributions right now, all the OS vendors are all rapidly deploying patches. But if you're running a really old version, like in the case of a demo I can show if you're interested, just tell me in chat, a demo of using the standard app package, not the Docker ones that come from Docker, which is always what I recommend if you're going to run Docker directly without Kubernetes. You use Docker's scripts from git.docker.com. You're using their distribution of Docker, not like Ubuntu's distribution on the apt servers straight from Ubuntu. Ubuntu, they control versioning, and as of yesterday, when I ran a regular 2204 LTS Ubuntu, those standard Docker IO packages install older versions, and they're like way older. They're not just like the version from 2 months ago or whatever. They're old, so those are going to still be vulnerable. And that's how I actually did some of my testing, was just installing the standard packages from Ubuntu. If you pin versions of Docker, Containerd, and Runc, then you might be in trouble. What I have noticed is depending on how you install Containerd, Containerd may or may not pin the version of Runc as an apt dependency. So the good news there is that it looks like you can just upgrade your Runc. You can leave Containerd alone, provided that you don't have like a 5-year-old version of all these binaries. So it is just a patch release, so it should be compatible. A form irregular. Nirmal's not coming today. He is traveling, so he will hopefully be back next week. I think we have guests starting next week. Is this fixed with the apt upgrade, James? If you install Docker through the official Docker packages, then yes. What I don't know so Docker, I believe, when you use the Docker packages, they ship their own version of Containerd and the Runc shim. And so we can actually look at the file system and see the relationship here. Let's just jump on just a quick little demo. This is going to be a short one. So this is on a vulnerable system. So if I do a Docker version, you'll see that my Runc version is 117. Now the fixed version is 1112. So this is me on the default that comes with Ubuntu 2204. And so you can see the versions are a little older. I also have another one. I have a lot of machines here. What's the name of this one? This is Docker new version. And Docker version here has the 112. So if I'm using the Docker scripts at git.docker.com or basically the Docker docs to install the correct latest version of Docker. When you install it or when you do an app upgrade here, you're going to get the fixes. All right, and the Docker engine technically was fixed in 2502. The only reason that you need to care about the Docker engine version is if you're using the classic builder. And the classic builder cache, in the same way the BuildKit cache, it can also be corrupted in essentially something built with a nefarious Docker file could escape the build, corrupt the cache that would potentially affect future builds or have access to other builds, right? So how can we find out repo or cluster impacted by Runc? So that's a great question. You would essentially need a utility, a tool, to check the Runc version. And so you can either, in the case, for this example, like right here, I have an image running. And in case you're curious, if I do a PS, we can see a lot of our containerd and Docker stuff down here at the bottom. So this is a standard Docker engine. And if you didn't know, when you do a Docker run command in the CLI, it's talking to the Docker engine. The Docker engine then talks to containerd, and then the containerd then tells Runc to run the container. Now, in the case of Docker engine, you'll see three things here. So you see the Docker D daemon, that's the Docker engine, and it's talking to containerd, running as a service. Notice these are all running as root because this is the default. And then the Runc shim inside of containerd is what essentially allows containerd to pass to Runc to tell Runc to execute the container. And you can see the nginx is run as a subprocess here. So when you're breaking out, if nginx was the Docker file or the image built with this vulnerability or this exploit, basically exploit built in, then it would have the permissions of whatever started nginx. Now, this is a little quirk of nginx, but nginx being like a lot of other common thread-based services, web servers, database servers, these are the actual processes that take user connections, and they're run as they're not actually run as systemd. This is actually a little bit incorrect. If we get into PIDs and subprocesses and IDs of processes, the IDs on your host, which is what we're looking at now, are different than the ones in the container. They're not technically different numbers, but these little friendly names, they're just name assignments based on your password file. So these don't mean anything. The system doesn't use names. The system uses IDs. So, for example, if we did a Docker top, let's just do a PS real quick. So if I do a Docker top, which is Docker's host-based top command that runs to list the processes in the container, and I do it on this, you'll see I have this nginx running as the root in the container, which happens to be the same ID as on the host, but it's technically running in a different namespace, so it's not the same. It makes subprocesses, and these are the processes that receive user connections from the internet, which is why it's actually a little bit safer in the case of nginx. Again, we're just talking about nginx for a second. That nginx technically runs as root because it needs to be able to make, it needs to attach to 80 and 443, which are often requiring root. A lot of default Linux systems, they require that. So it's running as root, and then it's spawning subprocesses. So the theory is if nginx ever had its own vulnerability and someone were to have access, they would only have access through the thread or the process here running as a non-root user in the container. This has nothing to do with this vulnerability, but it's a curious thing. If you do the same thing with MySQL, you'll notice it starts subprocesses. Python, nginx, and other, Python, Node, other programming languages don't usually do this. They don't automatically create subprocesses. So a lot of people always want to say, well, I want to run nginx as non-root in the container. Well, you technically already are. The subprocesses there are running as non-root. I digress. The point here is if I actually did a Docker exec inside of that, and I just did a top, you would notice that it gives me the PIDs, but it recognizes the proper name to number association. So it's a little bit of a quirk with Docker. So I always end up running top inside the container if I have it, because then I can get proper association. And in this case, you can see that the subprocesses are running as a regular user called Nginx in the container. This doesn't actually matter. Either one of these users can break out into the host file system at startup. It's only during startup of the container that this can happen. And let's listen to a little bit of what's going on here. Let's go over to the let's go over to this podcast. Real quick, anyone got any questions? What is the difference between your Kubernetes course in Udemy and AKS? Can I be able to work with AKS if I complete your Kubernetes course in Udemy? Thank you for that question. I do not teach distributions of Kubernetes in my Kubernetes courses. I teach vanilla generic Kubernetes, which every single distribution uses, the standard resources, the standard commands, the standard makeup of a Kubernetes cluster. Once you've learned that, then you need to learn your particular Kubernetes distributions nuances. What networking do they provide by default? What ingress and storage do they provide by default? How does your cloud handle storage, backups, monitoring? Those are all very specific to your Kubernetes cluster. But regardless of any distribution, you have to know the basics of Kubernetes that are obeyed by every Kubernetes offering in the planet. So I still think even if you're doing AKS, I'm going to teach you all the basics of Kubernetes so that you know how to run it on your machine, on a server in the cloud, in a cloud's provided Kubernetes. And then whichever one you choose to use, you're going to need to go find a course or just read some of the documentation on how it does certain things, right? Because there's all these third-party tools that are usually bolted on in order to make Kubernetes a full-fledged solution. Good question. Would you please show a demo of how to exploit the Runc? So I'm not going to do that on the air. There are concerns on YouTube where if you are showing people how to exploit vulnerable software, your videos will likely get a strike or get taken down. So I'm not going to provide you a step-by-step on how this is broken. Just know that the most severe one, this one right here that was discussed with Docker, the 21626, and then also discussed inside of the Runc vulnerability database in their security tab in GitHub. And then it was first announced by Snyk, because they're the ones that found it back in the autumn of last year. And they have a wonderful breakdown of what this looks like. You can even see little Giphies that they do on the screen. I'll put this link in chat if you want to read some of those details. But to suffice to say, it's not hard to do. You're going to use the workdir. That's where this particular vulnerability is exercised, is using the workdir stanza inside your Docker file. And you're going to point it to a specific directory that has file descriptors. So I thought it was interesting, and we just should give credit to the team that found it. So I'm going to see if I can play this for you before we go any further. It should be at 16 minutes. So let's learn a little bit about Linux file descriptors and why that's an issue here.
How would the attackers exploit it, and just generally the story around this workdir directory.
So a couple of items of background, I guess, before we get into the actual vulnerability. So on Linux, when you're interacting with files or directories, etc., you'll open them and then your process will have what is known as a file descriptor. In practice, it's just a number, but it's a special number. It's tracked by the kernel, etc. For our purposes, there is a number and there's a certain directory in the proc file system, which is like a introspection file system. You can see a lot of information about your own process, about other processes, and there's a lot of detail there. But for our purposes, there is a directory in there where you can list all of the file descriptors for your own process. It's used for things like, automatically closing anything that you don't need open, or validating, certain security expectations by reusing an open file descriptor. And it's very useful for us, as we'll see in a second. Another item that's, I guess, worth discussing is these file descriptors are inherently privileged, especially when it comes to containers. anything that you open will then stay open for all of your children processes, or in this case, containerized processes. So file descriptors are inherited, but they are the access requirements, or sorry, the access provided stays the same no matter who inherits it. So Runc, as the kind of relevant component here, makes sure that by the time the container is running and the control is handed over to whatever processes is running in the container, which is usually, user supplied, so your main entry point process in your image, Runc will ensure that all of these file descriptors are closed. If they're not closed, it's a file descriptor leak, and the processes inside the container could then potentially do things with those file descriptors, which is potentially bad.
All right. So essentially what he was saying there was we have these things called file descriptors, standard Linux thing. And what the sort of the problem with Runc was that there is a potential during the startup of a container, and in BuildKit, it's also during the startup of the build, because when you build a Docker image, you are running containers to do that work, is that the file descriptors for the host process, the Runc itself, that maybe were open at the beginning, but they haven't essentially been shut off from access inside of the Docker file executing or the container starting. And they're supposed to close down explicitly, but they were actually being closed down implicitly. So there was a potential moment where your application inside the container starting up had access to file paths on the host file system outside of your container. So it just happens for a moment, and it uses a file descriptor ID, which changes. So you kind of have to do this trial and error thing until you get it, which means someone would literally have to have something running and trying it over and over and over again. And if they get the right number, it wasn't that many options, but if you get the right number there, then you essentially can read and write as the user of Runc, which typically is root, to any file part of the file system. So that means you could update the cron tab. That means you could add a user to SSH and drop in a key. You could, if you do something, you could probably, I think there was a theory where you could probably execute another Docker run command against the host Docker socket, which is a file, and you could mount that. And then if you had utilities in your container, maybe it was if it's already an untrusted image that you're running and it already has this exploit, it might have a lot of common utilities in it, including the Docker CLI that would then mount the Docker file socket from the host, would have root access to that, and then be able to run any Docker command as root, and so at that point, they can do whatever they want, right? They can start processes, they can start them on the host, they can write any file to the file system, they can connect out to something remote and provide a reverse SSH tunnel back in if they have access through the firewall. Essentially at that point, your system is under the control of the attacker. And this in container land, we call this container breakout. And this has happened a few times before for various reasons over the last decade. They've always been a big deal, because there's two things that we assume when we run containers. And this is like two core premises of Docker and containers in general that are broken by this vulnerability. The first one is that when I run a container, let's just talk about files for a minute, because that's really what this is about, file system. When I run a container, the things that are running inside that container as processes have no access outside the container file system unless I specifically give it. So that's assumption one. And assumption two is me as a container operator, when I do a Docker run or kube control run or anything like that, and I don't specify a bind mount or a volume, same thing. If I don't specify one of those two things, then I don't have to worry that the code I'm running in that container could get out to the host file system. I trust the kernel is relatively bug-free, and that the Docker engine is bug-free, and the containerd is bug-free, and that Runc is bug-free, so that none of those steps can be exploited, so that whatever's in that container can break out. So both of those, from someone who's just running a container and knows, okay, I've only bind mounted code in from my code repo directory inside of my user profile, and that's the only thing it has access to on my host. Like, there's those kind of people. And then there's people like operators that are, or maybe you're a security tester yourself. Maybe you're a security person that wants to run something untrusted, but you're going to run it in a container because that's the safest way to run untrusted code. I love running untrusted code in containers. It's a little bit easier on Mac and Windows and Docker Desktop because it's running inside a VM and then inside of Docker of that VM. So in this case, it can break out of that container even though I didn't allow it any permissions to the host file system. No bind mounts, no volumes, nothing. It can still get out if it's a vulnerable image, if I've run someone else's untrusted code that I didn't inspect. All right, so if that happens, if it's in a VM, it can't break out of that VM. That would require some sort of VM hardware driver vulnerability, right? So when you talk about how do you mitigate this, which was a question earlier, one of the ways is if you are a provider of container resources, you're probably running something like Firecracker, Kata containers. These are things that take the idea of a container and then they wrap it in another shell that's running a Linux kernel, and it acts like a VM. That means that this exploit wouldn't be able to break out if that was the only container in that little mini VM. It can break out of the container, but so what? It's still stuck by itself in its little bitty VM. It can't truly get to the real host running that. So I guess one way to mitigate is run everything in these mini VMs, essentially. I don't know what we should really call them, that are usually run in clouds by the cloud hoster or by anyone providing infrastructure as a service or running untrusted code as a service. If you're a bank and you can't trust these 3 different departments to run their apps on the same server, and you don't trust that because if one of them runs a vulnerable app, it might be able to get to the others, you would probably run something like Firecracker or Kata to isolate each one of those untrusted areas so that you further reduce the risk of something like a container breakout being a real issue. So there's that, okay? That's something that I don't see a lot of people doing unless you know you're running other people's code. If you're running CodePen, you're definitely doing this. If you're running any sort of, Heroku type service, you're definitely doing stuff like this because you want each one of your customers to be guaranteed more than just, we hope there's no bugs in Docker, right? You want to put a kernel and hardware definitions around that so that even if the container runtime is vulnerable and even if the kernel is vulnerable, that it can't break out into the host. All right, that's a good question. Yeah, Alex is saying, I run Rancher Desktop installed on Homebrew. So you're not going to be looking at the version of Containerd. You're going to be looking at the version of Runc, which if you just do a Docker version, if you're running Rancher Desktop and you're only running Containerd, then you should, I actually have a screenshot because my Rancher Desktop asked me to upgrade. And when it did, it told me that it was patching Runc to version 1.1.12, which is the patched version of Runc. And that's what caused the Rancher Desktop to upgrade. So even though it's using Containerd, you have to go find that Runc version. And to be honest, I'm not a Rancher Desktop expert, so I don't know how to tell you to do that on Rancher Desktop. I don't know how to go look at the version of that. And I don't want to start it because I've got all this live stuff happening, and I don't want to go starting Rancher Desktop. It can be a little heavy on the processor. How does a container break out of the host machine? I think we've already explained that. Let me know if you have any other questions on that. Yeah, so let me give you the audio link. It's a good question. Here's the audio link to the podcast from the researcher that found it. And it's pretty nice because he steps through how he went about his job of finding bugs and how he eventually thought that this might be an issue and then what it really means. And yeah, so it's an hour long, but it's a good, if you really want to understand the internals. If you just need to know how to mitigate, this is not really the podcast for you. This podcast is more about the discovery and what that means for container tooling, right? So what else we got? Another way to mitigate this is that because the breakout, and this is true of a lot of the breakouts over the years, not all of them, but any way that someone can sort of break out of a container or be able to do something on the host file system without having implicit permissions given by Docker, like through a bind mount or a volume command, it's usually involving you breaking out and having the same access as the container runtime. Now, regardless of what we mean by container runtime, it could be Docker Engine, it could be Runc, it could be Containerd. But there's been two ways with Docker over the years that could also, and one of these can also be done, I think actually both of these also can be done by Containerd in Kubernetes, is that a while ago, a long time ago, 6-7 years ago, my friend Phil Estes, who's going to be on the show, Phil's going to be here talking about Finch from AWS. Let me actually find out when that's going to be. I'm actually forgetting if we have that on our list. Finch is February 22nd. So we're going to have pSQL. We're going to be talking about pganalyze next week. We're going to be talking about Finch, which is an open source tool for running containers on your local machine, provided by AWS. And then Portainer with Neil, the CEO and founder of Portainer. A lot of you use Portainer. They're going to be on at the end of the month. So in case you're curious about future shows. All right. But Phil was someone who worked on a feature in Docker, which doesn't get a lot of talk, but I used to talk about it all the time, called user namespaces, or user NS. And this allows Docker to run as root as the daemon, but when it spawns Containerd and Runc, it uses a unprivileged or low privileged user to do that. So this would help mitigate this, because if you break out of a container, but your user ID is 1001, you typically have very little access to anything other than to maybe read some stuff. You can read files maybe, but you can't read a lot of stuff in etc. You can't read stuff in the /root. You can probably only write to files in temp. So you can still do some damage, right? You can still maybe fill the hard drive. Of course, you can always fill the hard drive from a container's perspective and DDoS a server. Or not DDoS, but just DOS a server. So one of the ways is to enable user namespaces. So just look that up, not user namespace. And it's not the same thing as Kubernetes namespaces. That's totally different. But a feature in Linux called user namespaces. And the one challenge with it that I believe is still the case, which is something I was hoping they would add later on. I don't think they ever did. I think we were waiting for C Groups V2 before this ever happened. And I'm not sure it ever is yet to happen. I have to check. I'll have to actually remember to ask Phil when I see him in a couple of weeks. But what we really wanted is the ultimate security is Docker runs at root as root so that it can do the things it needs to do with file systems and other things that, accessing GPUs in case you're running that kind of thing, ML and AI. But for each container, it creates a new user ID, 10,001, 10,002, just random IDs that have really no permissions anywhere on the system. And each container, it spawns up as a new user on the host. That is not something that we have today. What really happens with Docker is it launches all these as a single ID. So if you break out of one container, you can probably figure out a way, if you're that savvy, you could probably figure out a way to get to the other containers and then sort of have access to all of them because they're all running as the same user ID. So there's that. Then there is Rootless. Now, a lot of tools can run Rootless. Containerd can run Rootless. Kubernetes now supports Rootless. Docker has supported Rootless for a long time. Podman runs Rootless in various ways. Podman, by the way, still runs C in a lot of cases. If you were not here at the beginning, we had a fantastic person point out that in Red Hat 9, Nidesh, sorry if I mispronounced that, that Podman in RHEL 9 does not use Runc. It uses a alternative called crun that Red Hat makes, which is, to my knowledge, the only alternative to Runc. So when you think of any container tool in the world, they all use Runc, no matter what they are, except for this one case where it's got to be RHEL 9, as far as I know. It's got to be Podman, and it can use crun as a drop-in replacement. The difference there is Runc is more stable, much more widely used. I mean, I don't know that C-run by Red Hat is unstable. It's just I've never actually seen it run anywhere. So it's news to me that it can run inside of Red Hat 9. But C-run is a C++ app, and Run C is a Go app. So Red Hat argues that C-run is leaner, maybe a little, a few nanoseconds faster, microseconds faster, something like that. But it's just not heavily used. So it's not really something that and I don't even know if it's vulnerable. It might have the same kind of vulnerability, but it was written in a completely different language. So I have no idea how it looks at file descriptors in terms of when it starts up a container. Yeah, so that's a good question. So could hackers be exploiting these vulnerabilities for years? How would you detect such exploits? Okay, so let's just talk about this particular Run C one since it's so prevalent. The rest of them are all in the build phase, and they're usually by BuildKit. And you would have to have in the build phase, it would only affect your CI solution that built it, and it would have to be a Docker file exploiting this specific vulnerability, which means you're building someone else's untrusted code that you didn't approve. So hopefully you're not doing that, right? Now with Run C, this has to run a container that has been exploited, right? So the container itself has to want to map certain directories that have no business being used in a normal startup of a container. So someone has to specifically go after this vulnerability, which means you're running a container that you didn't trust, you didn't vet on your infrastructure, which you probably aren't doing, right? So if attackers knew this, if someone knew this zero-day exploit from years ago, they would still have to attack your supply chain first. So the real question is if they can exploit your supply chain and just change a line in the Docker file that quite frankly makes the Docker, whatever else was in the Docker file probably doesn't even work. Because if you're changing the work dir, then that means your app isn't running from the directory it expects, which means your apps weren't going to work to begin with. It would be very, very specifically targeted, very crafty person to have to, one, figure out how to inject something into your supply chain, get you to build a Docker image that you didn't expect to build, and then two, hide it nefariously in there so that your app still runs from its correct directory, but there's this other one that's somehow bind-mounted, sim-linked something, so that they can then exploit the production systems. My theory is if someone can already exploit your supply chain like that, where they can make you kind of run something untrusted, there was already way more things happening before this, and this is probably the least worrisome thing. Because if they can exploit the systems that build your Docker files and that you can exploit the actual image you're running, they can steal all your user data from your database. They can do anything. Why would they want to do this is my argument. Why would they bother with this little thing that would then force them to have to then craft a hack for the host operating system so that they could command and control it? It just seems unlikely. So I'm not saying that it doesn't exist, but those are the kind of people that are very targeted and very specific. Now, you can run tools to scan your systems or scan your Docker files, and Snyk has provided a couple of those. We can also talk about other ones, but Snyk provided two. Let's go just check out. So there's the leak. They're all this stuff is named around leaky vessels. That's just a Snyk term they defined for all this stuff. We always get good, the good hacks out there always have a good name, and leaky vessels is a good one. So this dynamic detector, which is mentioned in that blog post I mentioned in there, this tool can run on your hosts. So let's see what it says here. So it's running as eBPF. So which means it's talking to the kernel at the host level. It's watching system calls come in, syscalls, and looking for suspicious ones that meet the requirements for this specific directory that it's trying to call. So it hooks into Linux syscalls and the function invocations of the Docker daemon and associates them with Docker builds and container processes to identify exploitations of these vulnerabilities. So they kind of define the different vulnerabilities, and then they talk to you about how to compile it and run it. Now, this is just for notification purposes. This isn't going to like block it. This isn't going to stop system calls. There are potentials for false positives here because these are just directories and they're used by other things in the system all the time. So they list some limits here. Yeah. Requires root access to run this because it requires eBPF. The runtime workdir exploit happens during container initialization, so it won't be detected on running containers. The detection also assumes the container runtime is containerd, so it's only designed for that, which is fair. In Kubernetes, modern Kubernetes, containerd is the default, so that's fine. And then they have a static analysis tool. So this is a tool that you would run on your Docker files. You could do a simple regex or a simple find, or I use AG, so the Silver Searcher. You can just use that tool like that against your repos to look for the workdir pointing to proc self fd. Okay, so it's technically a subdirectory of that. But if you look, the workdir proc self fd, that is the red flag, right? Now, the ID will be different on each system and dependent upon the way you run it. That's why you have to end up trying this a lot of times. And people can actually use this with an additional run command to do symlinks and do other things so that they can have access later from a different location so that it won't be so obvious, which is why this can sometimes be worked around a little bit. So your mileage may vary. They do warn on this static analysis one where they're just scanning for your Docker files that someone could really do a lot of things to try to hide the fact that it's trying, it could do trickery inside the Docker file to, change the argument. Like I was actually testing one earlier where I would change that file path based on a build arg so the Docker file itself wouldn't really have the full path. It would be something that would be manually typed in at build time. It just all depends on what you're trying to do. If someone already has access to control Docker build commands, obviously they have root, they have complete access there. So this is not something they would probably do. So you see here, like in this one, this is the command that would do the workdir, right? This would change the work directory to this location that potentially could have root access on the host. And so it's going to scan for that. So you can use these. Now, someone on Twitter, I actually put this up on Twitter. I retweeted someone. Yeah, so this is an interesting idea. Is a Kyverno policy. So Kyverno has been on this show, and they're going to be on again this year. And Kyverno is a Kubernetes-specific policy engine that helps you protect from all sorts of bad behavior. We've talked about it on the show before. And Kyverno allows me to do things like make sure that people only use approved registries, or make sure that they don't run anything with the latest tag, or makes sure that you can just sort of prevent and enforce all sorts of good and bad habits with Kyverno. And it does block. You can put it into either monitoring or blocking mode. And so the scenario here is if someone was changing the work directory, it's kind of hard to see there. It's basically going to say block, validate, failure, action, enforce. If someone is trying to change the work directory to this location, and it then would put a message out of you're trying to use a working directory in this location. So that's a pretty cool prevention mechanism. If you have Kubernetes clusters all over the place, you already are running Kyverno as your policy engine, which I recommend. It's a great one. It's easy to use. As you can see, this is pretty self-explanatory, right? Like this isn't something like Gatekeeper where it's a totally different language that we don't understand. That's what I love about Kyverno is that its policies are kind of intuitive and you can just sort of read through the YAML and it makes sense of what it's doing. By the way, Kyverno is a CNCF project. You can actually go look at policies in here and you have, just sort of pick the thing you care about, right? Let's say we care about, let's do pod security standards, like right here. So like disallow privilege escalation, which is something you always want in pods. And in my own pod spec, which I talk about on this show a lot, I have a free pod spec that you can use that is on GitHub that gives you a lot of security features out of the box. It's just github.com/Bret Fisher/podspec. I'll put this in chat. So in this one, there's a lot of security features, right? It's just standard pod security stuff. But if I tell my developers to put this stuff in every one of their pods for anything they ever run a pod with and do all these things, and then they forget, which sometimes we all do, this is the kind of policy I can put into my clusters to prevent or basically enforce the good behaviors, like don't run as root, don't allow privilege escalation. So this is just a sample, a policy that you can copy and paste into Kyverno running in Kubernetes, and it will help you prevent that privilege escalation. So anyone who tries to deploy a container that needs privilege escalation will get denied. And instead of you finding out later that someone did something bad, you can basically prevent the bad from happening. So I don't know this person, Lobu Hi, but this is a great idea. I have not tested this and tried to use the exploit on a vulnerable Runc, but it seems legit. Like there's potential there. I would really want to test this thoroughly before I would believe it's there. But if I've already had Kyverno in play and I'm already using policies, I maybe would throw this in just as an extra precaution. But my real solution is going to be just upgrading Runc. Like that's my final. But this is something that this is maybe a way to know if your supply chain has been attacked. Because if someone's trying to exploit this vulnerability in a Docker file or in a container on your systems, that's either an internal engineer that's doing something very bad. So you now have a person with permissions that is doing something malicious, or there's something that somehow has become vulnerable in your supply chain, and a rogue entity has then updated Docker files unbeknownst to you, and they've gotten all the way through to clusters. And so when the cluster tries to run it, it's going to fail. So I think this is actually a really cool idea. This is the thing that I would use if this was me. Now, we still have Falco, and you've had Falco on this show before. Falco is an engine that monitors at that eBPF level. And what I'm curious about is if we could figure out a way in Falco to detect this as well. So Falco is something that if I was running Kubernetes clusters, I would be running Falco on each node as a part of my monitoring solution, and particularly as a part of my security monitoring, because Falco can do things like monitor to make sure no one creates a shell on a production server, which shouldn't be there. No one runs a kube control exec, which should never happen in production unless you're troubleshooting. And when that happens, I want everyone to know. So you can have all sorts of rules in Falco to monitor for those bad behaviors. And they have a whole set of default rules that they talk about in their documentation. This is a very common tool. It's used all over the place. It's been around for years. I trust it. And this is not as easy as Kyverno. In my opinion, Kyverno, it's great because it acts as a controller. I can use something like Argo CD to auto-deploy my Kyverno policies to my clusters. Whereas Falco, up until very recently, Falco didn't really have an easy automated update and rule changing ability. It was a little bit more of a traditional outside of the Kubernetes solution, but they've recently started to update it so that you can manage it centrally and not have to do a bunch of installs on the host file system or change things on the host file system. So I have not tried this either. I haven't even done a search to see if Falco responds to this vulnerability. So let me go grab the vulnerability name here. See if anybody's talking about it. Ooh, look at that. Sysdig is already talking about it. Sysdig is the company that sponsors the Falco project. I think they're the original creators. And detecting leaky vessel exploitation in Docker and Kubernetes. Let's see. All right. Let's look. The following Falco rule will detect and affect container runtimes trying to change the directory to a proc file descriptor, which isn't a normal activity. This rule should be considered experimental and can be used in OSS Falco and Sysdig Secure as a custom rule. So there you go. There's another way. So what are we up to now? We have 4 different tools that will detect and let's see, and we have 1 tool that will block. That's the Kubernetes. That is my brain just stopped working for half a second there. When we're talking about Falco, I don't believe that Falco can block. I think it's just a monitoring tool. But Kyverno is the one that can actually block. All right, any questions so far? I know we're over an hour in, so I want to make sure that I'm getting all your questions answered. If you're new and you didn't go to the beginning, it's okay. We can answer the same questions again. I can go through that. Now, one of the things about Rootless, one of the things I wanted to show off was not a lot of people run Docker Rootless because it's not the default and everything works, so why change it? So let's just look and compare a little bit of the basic differences between Docker Rootless, which would help mitigate this, right? Because if you're breaking out, the whole rules of breaking out of a process are that when you get to the file system or when you get to launch your other process, you're usually going to inherit the permissions and the namespaces and cgroup stuff of, maybe not the cgroups, but at least the namespace of whatever the process was that started you. In this case, because a lot of these tools run as root, you are root when you break out. If you run it as a least privileged user that you basically create just to run Docker Rootless, then in theory, there's not a whole lot they can do. They can write files to a very limited set of locations that are not sensitive. They can't read sensitive files that are root only. They can't read passwords. They can't read stuff in the root directory. They can't change binaries. They can't install software into the host system that would sort of over or replace host file system things, right? They can always probably download a binary into a temp directory somewhere, but running that as root to be able to change things would be much harder. So if we look at Docker Rootless, there's a whole guide. There's a whole guide to this, in case you didn't know. And the way you get the rootless install of Docker is normally you type get.docker.com. If you're taking my courses, you know that you install Docker by going to get.docker.com, and that gives you the script. Now, if I change that location, though, to /rootless, I get a script that will try to install this as the user I am when I install it. And so if I were to jump into a default server as the Ubuntu user, and then I ran this script, it would put all these files, all the typical files in my user directory, would run Docker daemon as my user, and everything would be in my file path, so /home/Ubuntu, let's say. Or if I create a brand new user with no permissions, just calling it Docker Rootless, and gave it a user ID of 1001 on my, 1010 or something on my host file system, then when I run this, all those files that we would normally see in user bin and varlib will now all be inside of my user directory as me. And Docker is pretty great in their documentation. If you just search Docker Rootless, they explain some of the known limitations because not everything is doable with Docker when you're running as a normal user. Specifically, the biggest things that we care about is if you're using Swarm, you can't use overlay networks. So basically Swarm isn't an option for Rootless. You can't use things like AppArmor. SCTP ports isn't that common unless you're doing some advanced video stuff or whatever. I think that's what SCTP is. That's not normal for people. Weird little things like the ping command, because it technically doesn't use TCP or IP. Ping uses ICMP. So that has some quirks. And then exposing privileged ports, which is also another big one, where usually you need to run a Nginx or a traffic proxy in Docker as your incoming proxy on port 80 and 443. But you can't just do that by default because those are privileged ports. And there are ways to work around these. Each one of these has their own process for maybe changing something on the system or maybe running commands temporarily as root. It just kind of depends on what the problem is you're trying to solve. But this is it. This is kind of the known limitations. That list has actually gotten smaller over the years. So this is a better list than we had maybe 4 or 5 years ago when Rootless was new. Yeah. Look at that. Yeah. What's up, Pseudo B Mitch? So, yeah, Rootless has, this is a great point because Rootless, he says, consistently breaks or constantly breaks people. The UIDs are mapped to high number values they can't access on the host. And it does get weird, especially if you're a developer trying to do this and you're trying to bind mount code or you're maybe trying to think of what other scenarios there. I also experienced this with user namespace Docker, with volumes, mapping volumes and stuff in namespaces where I remember there was a quirk one time where Docker creates the volume as root and then the user that wants to do stuff in it is this non-privileged user. Like you will run into issues. I don't know anyone that's tried to implement Rootless and not had some sort of pain, right? There's always a pain. So that's why Rootless isn't the default. That's why we don't tell everybody to do it on day 1 or even day 10, because it's just another problem and a barrier. And if you're not well versed in it, it's going to be a headache. It's going to suck. So people just don't do it by default. Kubernetes and Docker for years didn't even have a way really that was well documented at all for running Rootless. A lot of code changes had to happen over the years. And then there was a sort of a moment in time where all the projects were saying, okay, we now can at least support basic functionality in Rootless. Yeah. So where are we at? This is an interesting question. How do you forbid running a workload as root in Kubernetes cluster wide? We just showed that. So the way, well, there's a couple of ways. I mean, one is if there's nothing in Kubernetes running as root, then it can't run containers as root. But I think that's a little more advanced. Really, the Kyverno is one of the first ways I would do it. You can do it at the workload level so that if all of your Helm charts and anything that's going to be run in your cluster have to go through a PR process, you would always have a PR process review where you would ensure. So that is sort of a human-driven approach. That is not what you're asking for. But if you're looking for your team to always be using something like the pod spec here, where you make this false, right? You make privileged false, you make allowed privilege escalation false, you define the user that's going to be run as, so you hard code it, right? This part here actually turns on seccomp for a little extra added security. But the real way I think in Kubernetes that I would do is implementing something like Kyverno or another one of the policy engines that would see the workload coming into the API, scan it for anything that you don't allow, and then block it from being created as a resource in the first place. You don't get that level of control in Docker. Docker doesn't really have this idea of a policy engine in the front that guards against bad behavior. But to me, Kyverno is the Kubernetes cluster operator's tool to enforce good behavior and prevent bad behavior. You can do things in Kyverno, and by the way, go back on my channel, search Kyverno in this channel. You'll find the creator of Kyverno coming on, who he'll be back on this year because we're going to talk about new features. But he will talk about Kyverno. We'll look at policies. We'll talk about how they work. And let me see if I can't find. We were just on the Kyverno website. I don't know why. I can never find the tab I was on. But if we go to the policies, like we were just showing, you even have mutating policies that won't just say no. They will actually change things to fit how you think they should be, right? That's a mutation. So we can say, let's turn off Argo and let's just go down to pod security because that's kind of what you're asking for. And I want all of these. Yeah. All right. So privilege escalation, right? This is the one I showed a while ago. So this policy, and I even tell you, privilege escalation, such as set user ID or set group ID for file mode, should not be allowed. This policy ensures that the allow privilege escalation field is set to false. And so you can apply this to the entire cluster once Kyverno is installed, and you apply this to the whole cluster. And the nice thing is with Kyverno is that when you run, if you tried to break this with a kube control run command, or you tried to apply a policy, I'm sorry, not a policy, a YAML, a pod YAML, you actually get back a nice error. We did this on the show with Kyverno. So it's not this mysterious thing of you deploy and everything seems fine and then nothing works. It actually will reject what you're trying to do. All right, and this policy isn't that long, right? And you can even see down here, it's sort of got a pattern. Let me look there a little bigger. It's not too complicated to understand, and that's how you would do that. Yeah, Zolt saying that's another thing of Rootless is you maybe can't use the host network. So if you, yeah, networking is just generally a struggle for Rootless. So, you have to be very deliberate and very careful. All right, what else have we got? Take a sip of my coffee real quick. All right, let me look at some of the rest of my notes. So for those of you that weren't here at the beginning, we're talking about Docker, well, Snyk announcing Docker and container tooling vulnerabilities last week that are high, not critical, but high, that allow someone with basically a hacked or a vulnerable, I'm not sure how to say that, not vulnerable isn't the right word, an exploited container image or an exploited Docker file that has a specific set of things going on in it that weren't there by default, weren't there normally, can break out of the container file system in a lot of different cases. And the way to fix this is to just simply update all your container tooling to the latest versions. Or, depending on what tool you're running, because I went through the list, right? I went down all these vendors. I went over to SUSE, looked at their list of container products, which all include Runc. And they talk about which ones are updated, what versions that are the most current. The same thing with Ubuntu. The same thing over here at AWS. AWS has dozens of container tooling things. Now, in some cases, they may be using Firecracker. They may be using other things to mitigate or reduce risk. They might not even be using Runc in some cases. But you can see there's a pretty good list here of things on AWS that deal with Runc. And so your clouds are going to be updating. You're probably going to have to rotate or do something to your infrastructure in the cloud if you are manually installing these tools yourself. Yeah, so there's a lot. I mean, we're talking about hundreds and hundreds of tools out there across services of every cloud, every Kubernetes vendor, because they all bundle the containerd and Runc. They tend to bundle, right? They tend to pin versions. So when you go over to, let's see, what's the Kubernetes one that I like to talk about? Replicated open source. I can never remember. Open source projects. Curl. So Curl is this distribution maker tool, right? No, I don't want COTS. I don't want COTS. I want curl. Curl.sh. So this is essentially a distribution maker, and you can pick the tools you want, right? So when I notice that Runc isn't actually mentioned here, because when you install containerd, Runc is one of its dependencies. It may or may not pin the specific version of Runc. So you will have to kind of go and, buyer beware sort of thing. In fact, on the containerd project, what I should probably go look at is, yeah. So containerd 1713 updates the runc binary. So this is a dependency. So for example, if I go, we can just go look at this. If I go over apt show containerd, so this is an 17.2, so a little bit older version. Now this is with the default Ubuntu apt repositories, right? This isn't Docker's repositories. It's built by the Ubuntu developers. And it's an older version of containerd, and you can see its dependencies. Depends on libc6 and runc right there. All right. Notice how it's not specifying a runc version. So what I haven't done is done things like deliberately install an old version of runc and then update containerd and then see. Like you can do a apt show runc. And again, these are default packages that come with Ubuntu. These are old, and so far they haven't updated them to, this is a pretty old version, so they haven't updated it. But I don't ever install Docker or any container tooling from default Ubuntu apt repositories. I just don't, right? Because they're always going to be older than I want. And I don't believe that, as far as I know, none of the distributions of Kubernetes out there would use them either. Yeah, so Docker Swarm and Rootless kind of is not really usable because of the overlay networks. Didn't know that. Yeah. Yeah. I think I saw someone trying to sort of use admin commands to get the stuff working, and then I never really saw the end of it. I'm not sure if someone ever really got it to work, even though they were hacking it together and sort of cheating by doing some things as root, some things as not. But as far as I know, out of the box, Swarm doesn't work with Rootless. So if someone upstream builds a container with the exploit and I use that container, am I at risk, or is it only for build/Docker Compose that I directly create? If someone adds this workdir hack, essentially, into your from image that you're going to use, and you don't change the workdir in your image back to what you expect it to be, then yes, you would be at risk, and they could exploit you. So the from image is still, it's basically whatever the workdir is when the container starts, right? Because there can only be one workdir that's the final one when the application starts. During build, you can change the workdir 100 times, right? Go back and forth, do run commands here, change the workdir over to here, do some run commands. That's during build. You can exploit it during build, but that just exploits the file system on the build machine. When you're running a container image that has that workdir in it, when you're running that on one of your servers or your local machine, it's the latest workdir, which is going to be used in the metadata to start the container. That's the one that matters, right? If there's 10 workdirs in the from image before you, and then you change it to /app/my app, right? None of those other workdirs matter for running the container at runtime. Okay, it sort of like overwrites them essentially, because those are all now build artifacts, not what's going to happen at the container runtime. Hopefully that makes sense, John. It's a good question. Have I played with Firecracker support in containerd? It looks like it would be fun, but the project seems stale. I have not. Since containerd, it's been a couple years. So when containerd, this was actually pre-COVID now that I'm thinking about it, because I remember seeing it. I was watching Phil Estes talk about containerd, and when they started having all these plugin options where we could do all this fancy stuff, encrypted images, some other neat things in containerd, I did play around with a little bit of it. Might have run some Firecracker stuff, but I haven't done that. So that's, my gosh, that's like 4 years now. So yeah, I haven't paid attention. Tell me what you know. It says it looks like it's old. Okay, that's what you know. So yeah, now if I go over to compare, by the way, this is the new version of Docker, right? So if I do if I do an apt, this is a machine where I have added the Docker apt repositories, and I've installed the latest Docker engine as well as all of its dependencies, including, well, in the case of Docker, it installs an older version of containerd, but it does install the latest version of Runc, right? So yay. Yay for the win on the Simver there. It doesn't pin to a fixed version number. And that's what I noticed when I did apt show docker.io. Oops, gotta type that correctly. Let's zoom in there a little bit. So you can see when I look at my Docker 2405, this is again from the Docker. You can actually, this is the Docker new containerd 126. All right, so, and by the way, Docker uses different containerd than containerd that's used by Kubernetes. it's a little bit tricky there. But if we go look, I'm looking for the Runc. Oh, it just lists containerd as a dependency of Docker. And then if I do an apt show containerd, it'll show the Runc there again. And that's the apt source for containerd. And this is, let me check here. I might be using the wrong versions. Yeah, this is the apt source. So I need the Docker package. Hold on a second. Docker Ubuntu. So if we go down to the official, yeah, so it's not Docker IO anymore. That's what I was wondering. So it's apt show docker-ce. Now we're talking 2503. That's a more newer version. Then we have it's using containerd IO. And it still doesn't list Runc. So let's do a containerd. I think it's containerd.io is the Docker package. Yeah, see how we can tell here the app source is docker.com. So that it provides containerd and Runc. So in the Docker, and I didn't actually know this, I've never really paid attention to the containerd package coming from Docker, but the version of containerd is older, and it packages Runc with it. Interestingly, yeah, it conflicts if you install the Runc package yourself, which would come from Ubuntu, not from Docker. So I didn't really actually know this. I knew that Docker used a different containerd than if you used containerd for Kubernetes, but interesting. So so I can't actually really tell unless I do, I could do this where I install, I'm just going to copy and paste this in. Oh, I already have it. Okay. So there you go, 1112 of the Runc. I already installed this. I didn't think I installed it already. Yeah, thanks, Jake. I was merely pointing out that in Ubuntu, you can install Runc separately with the Ubuntu apt package. So for example, if I go over here, you can see that from the Ubuntu sources, I can install Runc itself, 117, an older version, and it's coming from the official Ubuntu sources. But when I'm using the Docker sources, it's containerd provides Runc for me, and it's called Runc. So if I do, let's see if it, Yeah, see, it's still pulling. If I just look at Runc, it's still pulling the Runc package. So Docker must not provide a separate package for Runc in their case. When you look also at the processes, you also see shims, which are the parts in between them. And so it can be a little bit we can see here, that's what Docker is running in the background to execute my container. And if we do, let's see, a PS with the tree, this is basically all the Docker stuff running on a default Docker instance. This is actually running the one that comes with Ubuntu. If I looked at the new version, I'm pretty sure, let's see, Docker run IT, and let's see, now we're going to do D. Just need to run a container. All right, so Docker PS, I have a container running, and then we see this right here, container D, a newer version essentially of the container D shim, and Docker itself. You can see container D running up there, and Docker D running right here, all is root. Let's see, where were we? I think I've covered everything. Yeah, so we've mentioned Kyverno, Falco. This thing is called Leaky Vessels, but I think right now the only ones really calling it that I can see are Snyk. And one of the FAQs I had is, can I mitigate by switching to other container runtimes? And not really, because the only one I know of that hasn't yet been found as a vulnerability is crun, which is used by Red Hat and Podman in very specific setups on very specific RHEL versions. So we're all using Runc as far as I know, and every major distribution that I've used of Kubernetes, it's always used Runc. So there's no real way to just swap it out for a different one. You're gonna have to just update. All right, we've been on here almost 2 hours. If you're out of questions, I'm looking through my notes real quick. Firecracker and Kata containers would limit you, or at least limit the risk, limit the exposure, because they wouldn't be able to break out as far, because they wouldn't be able to get to the host file system if they're in Firecracker or Kata. Kyverno could see and block them if you're doing GitOps or infrastructure as code related stuff, and all your stuff through Kubernetes is coming through YAML. Then you could do things through PR processes. You could maybe do some fancy GitHub actions that scan Docker files for anything in the proc directory for file descriptors. But Kyverno is probably, I think, kind of my vote for production Kubernetes operator level blockage of anything coming in, if it works. We don't know if that policy actually works that I showed here earlier. I'll bring it up again. Wherever I put it, it's inside of this Git. Not that pod spec. Yeah, right here, this one right here. This is one suggested on Twitter, and again, I haven't tested it, but in theory, if it's starting up and it has that work directory, it would block it. So I think that's pretty cool. I would if I was in a real important big production Kubernetes team, we would probably already have Kyverno running. We would just implement this policy once we tested on our test clusters. We would also probably already have Falco running, and we'd probably add a Falco rule like they pointed out here. I will point this in Slack as well. I don't know what Yuki is actually, so yeah. Yeah, so this is a change.dir, the chdir event. That's what it's looking at. And so it'll log it. It'll log it as suspicious behavior as a warning. I mean, warning. I I mean, I feel like if anyone's doing this, they're already like, there's no real. I have not seen a legitimate use for this, so like, it's not a warning to me. It's danger. Oh, and it's cool. I didn't realize they go through the other CVEs as well. All right, this is pretty nice. Good job, Sysdig. Very cool. Oh, it's the Rust Runc. Okay. Okay. Yeah, I mean, and if it's a feature complete if it follows the protocol, the OCI standards and the Kubernetes standards for the container runtime, then oh, is this is Red Hat's then, I guess. Yeah, I didn't know about this. Or maybe someone said it and I went, I got container D. I got Runc and Rust, similar to Rust. Okay. Yeah, I mean, this is the kind of thing where I can suspect that since this is announced, the C run and the Yuki or Yoki, however you say that, those teams are probably looking at their code to go, are we properly watching out for file descriptors to make sure that they don't hang around too long when we're starting up a container, which is the whole cause of this in the first place. So I suspect that one of the things that the Runc project did, when we go, let's see if I can find one of the project. If you go look at the source code of what they actually did, they put in extra checks to not just avoid it, but to also make sure it never happens in case things get out of order. So it's not a huge change in the source code, but it is specifically trying to prevent this from ever happening again in a container. Yeah. Look at that. Jake's got some advice on Yuki. I don't know how to pronounce it. Yuki. Yeah. So, if you're interested, this is a pretty neat write-up as well. I'm going to just put a bunch of links in chat for people that are coming in late. That's the Runc documentation about it. This is Docker's breakdown of the issue. And then this is one of the many articles on Snyk. In fact, if you wanted to read all of them, because they have 3 or 4 blog posts, you can just look at Rory's McNamara's blog post. So, he's got a new one, Deep Dive, that just happened a couple of days ago. I didn't see that one yet. So you can see all the blog articles he's written. And Yoki, okay, thank you. Yoki, got it. Yeah, so this Deep Dive, that would be something I think would be for those that are the kind of people that would sit here for an hour talking about it might be interested in this article. So I will have to be reading this after the call. Okay, so to wrap up, if you're still here, I want you to know about some things. First, Nirmal will be back next week, I think, and my co-host will be back. We're going to have guests starting next week, 3 weeks in a row of guests starting next week. Like I mentioned earlier, those guests will be, I have to pull it up again because I forgot. We're having Lucas on from the PG Analyze project, which is basically a SaaS to analyze the performance and configuration of Postgres. Evidently, it's quite popular. Recommended to me by friends to be on the show, so thank you. Thank you, Laura. AWS, Phil Esty is going to be here from AWS. I think the 3rd or 4th time on the show, at least for Phil. Docker captain, former Docker captain. He's been around. He's OG. He's been around the container game since the very beginning. And we're going to talk about Finch, a relatively new project from AWS. I think new as in like a year or so old. That is another way to install all the local container tooling on your machine. They started with Mac. Now they're going for Windows, so that in case you can't or aren't able to or don't want to run, Rancher desktop, Windows desktop, or not Windows desktop, Docker desktop, Podman desktop, you don't want to run any of those, and you still want to run containers, Finch is a project for you, or something to be considered at least. And then we're going to have Neil from Portainer, the CEO and founder of Portainer, Neil Creswell. Neil's going to be here. He's been on the show at least a couple times before. We love Portainer. We're going to talk about all the new features there, and then we're going to have Neil back on the show to talk about a new project in the coming months called K2D, which is a little mini container, not to spoil it for you, but a little mini container that can run in Docker to emulate the Kubernetes API for some resources, so that in really small IoT environments, if you want to take advantage of Kubernetes API-like functionality, but you don't want to have to run a K3D for all of its resource usage, you can do that on top of Docker with K2D. And so we're going to learn that project as well. We are honestly discussing with a bunch of other people for when they're going to be on the show. We've got KubeCon in Paris that I'm going to be going to next month, so expect a live show from there, bandwidth willing. Hopefully the bandwidth gods bless us again like we had in Chicago. We'll do another live show from there. So if you're going to KubeCon, make sure you jump into our Discord right there. Let us know you're going to be in Paris, and we will all meet up. We'll do a selfie. We're going to have a live stream. I can bring you on the show. We'll talk about it. And that's something we like to do at the KubeCons. And then, of course, this is where you're at now. You're watching me at Bret.live, so join the channel. If you want to be a member and get exclusive benefits, the whole gig. We've got the Discord. We've got the newsletter. The way you find out who's going to be on the show is the newsletter. That's the easiest way to do it. Just jump on the newsletter, Bret.news. You get a nice little short email every week that tells you what's going on in my content, what's going on my channel, what's going on the podcast. We talked, this podcast is, we're like on episode 140 or something now. We've got a number of episodes. So you can go over to the podcast, which is people from this live show get edited down into a short podcast. We've got a real short one coming out tomorrow, less than 40 minutes on LiveCycle, talking about internal development portals and internal IDPs, right? All the, or platforms, internal developer platforms, I think is the right definition of that term, not portal. It might have a portal in it, but that's not the real IDPs. LiveCycle is going to be on the podcast. They were on the live show 2 months ago, actually, and now we've edited that down for you audio listeners. So join all those things, however you want it. Video format, audio format, email format, it's all there. And I will be back with Normal next week with our guests. Thank you, everybody. I'll see you soon. Ciao.